Hello everyone. Welcome to Agilent Technologies Technical Webinar in Lab Indonesia. Today, we are going to share about how Agilent solution can improve your laboratory productivity. My name is Melda Tan, and I will be your moderator for today. Today, we are having a presentation from our speaker, Stephen Pang. He is our Agilent Spectroscopy Business Manager. Following the presentation, we'll be running live Q&A sessions. Before we start the session, I would like to go through some housekeeping. We'd love to hear from you during the presentation. So if you have any questions you would like to address, please send it to the Q&A window, which is on the bottom panel on your screen. When you are sending your question, please select all panelists in the drop-down menu and type your questions in the text box provided. You can ask your question in English or Indonesian language, whichever more convenient for you. We will be addressing all the questions during the Q&A session. And as time is limited today, if we do not get to your question during the session today, we will follow up with you afterwards. So without further ado, let's get things rolling. Stephen, you can start your presentation.
Thank you, Melda, and selamat siang to everyone who's online. So this is really a very unique way of doing a Lab Indonesia presentation, probably the first in its history. But nevertheless, as they say, the show must go on. And so we are here because we really miss seeing all our customers in Indonesia. All right. And perhaps when the situation improves, we can all meet up again in Jakarta. On that note, let us get started. I'm just going to see if I can get my laser pointer working. Yep, there it is. Now, this is the presentation outline. So this presentation is divided into two parts. The first part is where we'll share with you on one of the Agilent's next generation ICP-OES solution. And the second part of the presentation will see our introduction of Agilent's next generation laser direct infrared solution. For both presentations, our focus will be on the features and benefits, as well as how these features and benefits can actually help you to improve your productivity. So, the first part of the presentation, Agilent's next generation ICP-OES solution. The ICP-OES technique is not really new. It has been around for quite a long time. If you can see in this slide here, the pioneering work of Professor Fassel and Greenfield in the 1960s has established the basic fundamental or design of all ICP-OES systems today. You can see that basically the way that we can sustain the plasma is we have a plasma gas that's typically flowing, also known as the argon cooling gas, and that sort of cools the torch, but it also provides the gas that forms the plasma. The nebulizer gas is the section where we introduce the sample in the form of an aerosol into the plasma. The auxiliary gas actually serves to stabilize the plasma as it is in the torch. So in ICP-OES, what is being used is the fundamental of excitation of the valence shell electron to an excited state. And as this electron relaxes back to its ground state or in between the metastable states, it will inherently release back the energy that causes it to be excited in the first place. And because of this, we could have multiple wavelengths that are being emitted. And this can be measured with a suitable instrument such as the ICP-OES. And because of that, the ICP-OES technique has the advantage of being inherently multi-element without the requirement of a lamp source like in atomic absorption. Now, the intensities of the emissions from the various wavelengths of light are proportional to the concentrations of the elements within the sample. Some of you may know this as the very similar to the Beer-Lambert law, and this is what we use in quantification of analysis by ICP-OES. Agilent, as a company, has been involved for over 30 years with pioneering developments since the 1990s. For example, in 1991, we have a high-resolution sequential ICP-OES, and this was upgraded to Series 2 in 1995. The turn of the millennium saw Agilent moving into the use of solid-state detectors, such as the charge-coupled device detector that was first used on our Vista series, known as the Vista Pro and Vista MPX. These were one of the world's first and fastest simultaneous ICP-OES, and at that time, it was known as Varian, and Varian was acquired by Agilent in 2010. Since 2010, we have revamped the Varian, the previous Varian product line, and today what we are happy to share with you is actually a new ICP-OES family that first started in 2014 with some very nice features, such as the dichroic spectra combiner that allows you as the user to measure truly simultaneous dual view plasma viewing, that is the axial as well as the radial simultaneously. Now, this feature is something that only Agilent ICP-OES can do at the moment. Now, in 2019, which was just last year, we introduced our next generation ICP-OES, where Agilent again changes the game, and through the introduction of artificial intelligence-based smart tools, a new optics design, and with this has allowed us to improve the performance of the new next generation ICP-OES. We have two models, the 5800 as well as the 5900 that you can see in this slide here. So at Agilent, we're continuously innovating our ICP-OES technology. Now, I'd like to share with you before going into the details, with the use of a conceptual video, what this next generation ICP-OES is. What is behind our intention when we develop this next generation ICP-OES. It's always with the customers like you in mind that this next generation ICP-OES is developed. So let us have a quick look at this short video, shall we?
What is chemistry? It's the study of matter, molecules, and the atoms that make them, and the pursuit of the answers that lie within them. Answers to questions like, is this water polluted? Is it safe to grow food in this soil? But on the journey to the answers lie challenges, with some labs having to remeasure samples to get the answers they can rely on. Agilent has designed the 5800 ICP-OES to meet those challenges, with smart features to think like an expert, make recommendations, and solve problems before they happen. Its built-in sensors keep a sharp eye on your instrument, spotting and alerting you to issues like blocked nebulizers. IntelliQuant constantly examines your data to identify spectral interferences and make recommendations to ensure you get the right answer every time. Smart features of the 5800 make your first answer the right answer, so you don't have to remeasure samples, saving the time-wasted troubleshooting when things go wrong. Reclaim your wasted time with the Agilent 5800 ICP-OES.
In today's ICP-OES analysis, many of us normally take the cost of sample remeasurement as part of, as for granted. It is something that we have to do if we have to do it. Now, you can see that from the previous video, Agilent's intention, and we actually did an online poll, and from that poll, we found out that on the average, about 15% of our customers' samples are remeasured. And if we take this and break it down, typically for a small to medium laboratory, this will consume an additional 2 weeks per year. If we take a small and medium laboratory as approximately running 250 samples per week. And then if we were to look at the approximate costs of sample remeasurement, and this is where the story gets interesting. Now, for 40 weeks, typically, I guess it's the same from my visits to Jakarta, to all parts of Indonesia. Nowadays, in Indonesia, people work from Mondays to Fridays. Yeah. So if we take that, that works out to be 40 weeks per annum and 250 samples per week. And based on the argon consumption gas alone, all right, at 15% of remeasurement, this works out to be 300 Singapore dollars per annum that is being paid or extra costs. And I've actually checked that 1 Singapore dollars is about 10,500 rupiah. You can correct me if I'm wrong, Melda, but I think it should still be valid. Now, this is your basic costs. Your actual costs can actually be higher when you consider the impact of other sunk costs. For example, the cost of labor, the cost of utility, and for some of our service or testing laboratories, there are penalty costs where the sample results are not delivered. Now, let us look at the issues that lead to sample remeasurement for a typical test and measurement laboratory. Now, broadly, this can be categorized into sample-related. For example, whether during sample preparation, if you have added that requires both nitric and hydrochloric acid, if the analyst has forgotten to add hydrochloric acid, does the system have a means of informing you? Currently, as far as we know, no ICP-OES has that capability. But as you can see later, the new AI-powered ICP-OES from Agilent does have this capability. And when you're running your samples, if your sample is dirty and it's causing the sample introduction to be blocked, does your system have some means to tell you? Obviously, this varies according to the types of samples, but I'm happy to inform you that on the AI-powered next generation ICP from Agilent, we do have a means to inform our users. And also in terms of operation, when you're igniting your plasma and then your plasma fails to ignite, what are the potential causes? So the new smart ICP-OES from Agilent has the capability to give you some troubleshooting tips and tricks that you can do to overcome the plasma ignition failures. Now, obviously, to do this, we have to create some what we call smart tools. Now, these smart tools are no different from our smartphone. All right. So, because we are serving you, which is we consider you as our next generation of users. Okay, probably users like Melda, young and energetic. All right. So we need to add on some of these so-called smart tools, because this generation of users is very different from users that were probably 30 years ago, like myself, a bit of gray hair here. All right. So they interact very nicely with some of these smart tools that we have developed. So we have developed smart tools that will give you insights into both sample as well as operational insights. So in terms of sample insights, these smart tools are things like IntelliQuant 2.0 that allows you to have a full spectrum scan with automated spectral interference identification. It helps to identify sample preparation and chemical compatibility mistakes and allows you to understand sample composition. We also have an argon emission monitor as well as a screening feature which we can add on to the software that allows us to pre-screen the samples prior to analysis. In terms of smart tools for operational insights, these are things like NAP alert that alerts you when your nebulizer is clogging. Not that it's fully clogged, but it's starting to clog. So when the back pressure increases, it will send you an alert. We also have smart tools that allows you to conditionally format your results and to flag them, all right? And we have the early maintenance feedbacks that will pop up and tell you when you need to do a certain maintenance. We even have an automated air filter blockage. Now, this is the first, probably one of the first in the industry, because as we all know, ICP-OES require, or they'll take in some laboratory room air to cool the system. But what if over time, the air filter is clogged up? It's just like a car engine, you know, the air filter. And then you will find that you will get insufficient air, and this can lead to problems later on. Now, the automated air filter blockage sensor that we built into the smart ICP-OES will alert the user when this is detected. And to our pharma compliant customers, we have automated instrument performance tests that can be programmed for you to qualify your instrument to ensure that they are working according to Agilent's performance specifications so that the instrument is qualified prior to your analysis. We also have the intelligent rinse system, and this is a favorite of our application chemists because it allows the system to smartly apportion the rinse time from what is being programmed depending on the sample. If you have a sample that's very dirty, it requires the full rinse time of, say you program 90 seconds for rinse time, it will use up 90 seconds. However, if you have a clean samples that requires a rinsing time of only 10 seconds, the system will not do that 90 seconds, but stop after 10 seconds. And in so doing, you would save 80 seconds of argon runtime per sample. Imagine if you have 100 samples or 1,000 samples, testing laboratories can run even as high as 1,000 samples a day on several ICP-OES instruments. Okay, so we also have an internal standard monitor, just like that allows you to monitor the recovery of your internal standards. Okay, so these are some of the smart tools that were built into the system to assist you. So with that, the Agilent 58 and 5900 series are our two flagship models for ICP-OES. The key terms is they have AI-powered smart tools that I've mentioned just now. There's a new optical design, which I'll share with you shortly, and it has all these contributed to improve analytical performance. Now, one of the example of IntelliQuant 2.0 in action, which is not available in a lot of ICP-OES. Now, take, for example, if we were to look at the US EPA method 6010, now, normally, arsenic 193 is recommended for waste environmental samples. However, if your waste environmental sample is from aluminum smelter, then you will have relatively high concentrations of aluminum. And if you look at this spectrum here, you can see that the typical arsenic response with those elevated aluminum present is not really nice. In fact, my maths teacher would always say very ugly. All right. And then with IntelliQuant, you can see that the system smartly informs the user that, hey, you asked me to run at 193, but I'm giving you a 1-star rating because I think you should not use 193. But telling you that it's not so good is one thing, but what the user would really want is tell me which wavelength I should use. And IntelliQuant smartly informs the user, as you can see on the bottom slide here, that the 188 line should be selected instead of the 193 line, and it's assign it with a 4-star rating. All right. So why do we use star ranking? Is because this appeals to the millennial users. Now, you guys know that if a movie has 4 or 5-star rating, that one die must see, right? If a movie has only 1-star rating, maybe you can watch on YouTube or watch on Netflix. Okay, so we try to create systems that our user can relate without too much learning. You don't have to take a big book and learn what does this ranking means. This is intuitively programmed into the system, and the best part is you do not have to do anything. This is done for you automatically using the artificial intelligence that we have programmed into the system. Okay, good. Now I mentioned about a new optics. Now you can see here, all right, the two optical design. What Agilent has done with the new ICP-OES is to introduce the use of freeform optics. These are optical system in which the focal length is not just in a single dimension, but actually in a 2 or 3 dimension. And with that new patented freeform optics, what we have done, you can see here, the old polychromator of the 5110 is above and the new one is at the bottom. So your eyes will tell you that the new optics is approximately 50% smaller than the 5110. So what this gives us is a significant improvement in polychromator purge time and temperature control. And the benefits would be benefits deep UV lines, because then you don't have to purge so long to run those wavelengths that are below 190 nanometer. And it also benefits from the reduced Doppler shift emission of light as your room temperature variation, our polychromator are actually thermostated to 35 degrees Celsius. But if you turn off your instrument, you turn it back on, generally you will have to wait. And on the older instrument, we used to have to wait about 2 to 2.5 hours. But on the new Smart AI instrument, if you totally turn off your instrument, you turn it back on, we can get it up to the operating temperature in about 60 minutes. Now, that's an improvement, significant improvement. And that is also the reason why a lot of ICP-OES manufacturers will tell you, don't switch off your main instrument, just leave it in the standby mode, okay? I'll mention this point because there are some users of ours in Indonesia that, because sometimes the listrik may be fluctuating a lot, they don't want to take a chance and they turn off their instrument. So this feature is extremely helpful when you have those situations. Now looking at the new optics design and the Smart AI, what are the operating cost advantage that these systems can bring you? So again, looking at the US EPA protocol, it took the Agilent 5900, all right, approximately 58 seconds and 20 liters of argon. And if we put this onto a scale versus our competitors' instrument, you can see that both the 59 and 5800 in terms of argon consumption are 20 and 27, whereas most of our competitors are consuming above 40 liters. And this is because the time taken to run these analyses are about 0.97 minutes for this US EPA 200.7 method, 1.5 minutes on the 5800, and on our competitors is usually 2.2 to 2.4 minutes. All systems were running switching valve, so we're comparing apple to apple. All right, it's not like one system with valve and the other system without valve. And generally, as you can see in this slide here, the relative savings can be as high as 53% between the 58 and 5900. Okay, so there is incentive if you are comparing the 5900 over the 5800. But the real advantage is when you compare to our competitors, the savings can be more than up to more than 100% for some systems, because you can see that the analysis time about 1 minute versus 2.4 minutes. That's where your saving comes in. And this is on a per sample basis. So the more samples you have as your business grow, or as you have more and more requirements to analyze, your savings will also grow. Nice to know that, right? And this is where I hope you can see this should be the rupiah, all right? I have to wear reading glasses, so that's why I magnify this. Yeah, so you'll see the rupiah coming in. Okay, so bottom line, 55% faster than conventional dual view ICP-OES, approximately 50% less argon consumption, and giving you between 85 to 115% relative argon consumption relative to the 5900 per sample against competitors' instruments. Now, what about in terms of overall design? Okay, now here we're comparing between the next generation ICP-OES versus the previous 5110. They were good instruments, but we continuously strive to improve, okay? And this has resulted in 23% reduction. And in terms of the footprint, that's the bench space. And in terms of weight, that's a 15% reduction. So if you're wondering what is this, I think Melda is laughing or smiling there. This is also what I call the cabai rawit of ICP-OES. Small in size, but big on performance, okay? Right, we didn't stop there. We also have developed this application e-Handbook support because we recognize that you as a user, when you first get your ICP-OES, you also need assistance. And now in the COVID-19 pandemic, we can't really reach you face-to-face. So we've developed things like e-handbooks that we can send to you. And within this e-handbook, you can see that we've listed down all the different applications with the different sample matrices, but more importantly, the sample running condition. Of course, with the new smart ICP-OES, a lot of this is simplified for you. Even the selection of wavelength, which is the best wavelength now, is we've taken the guesswork out of that because the instrument can decide based on the artificial intelligence which is the best wavelength for a particular sample. All right, and this can vary on a sample-to-sample basis as well. So in summary, reclaim your wasted time. In case you're wondering who this nice-looking lady is, she's not a model, but she's Nancy, who's part of our marketing team. So Nancy is telling us, with this new ICP-OES, you can be confident of your analysis with the use of the artificial intelligence built in, and with that, you can run more efficiently, and you have more times to do any other things apart from just analyzing. Okay. So that brings me to the end of the first part of the presentation, and I shall now go into the Agilent next generation infrared solution. Now, infrared spectroscopy is not really a new technique. It has been well over 50 years now, or even longer. But basically, if you look at this slide here, I will not go through all the wordings. I'll just summarize it. It is just looking at how the molecule dances, or dance of the molecules. Okay, that's why I've got this this thing moving in and out when infrared light passes through it. Okay, so dance of the molecules. So if you play different music, yeah, so you have different dances because the different chemical bonds are resonating to the music. Okay, so your Gangnam Style, you have this. And then you have the jailhouse rock, you know, this is you have the rocking motion. But to the scientists, infrared is powerful because it allows us to do two things. Number one is we can have a spectral identification of unknowns, okay? To the ordinary people, these are just, you know, funny looking peaks here. But to the chemists, these are the dances of the different chemical bonds dancing to the different energy of infrared light that's passing through it, okay, resonating with it. That's one part, identification. The second part is if we have a functional group that rises proportionally to the concentration of that particular functional group, then we can perform a quantitative analysis of the sample components. So we can, with the infrared light, we can do identification as quantification in some cases. And because of that, the infrared technique is a very powerful technique that has found a lot of usage for over 50 years. Okay, and one of the attraction is the infrared is non-destructive. It doesn't destroy your sample. You can still retain your sample after the analysis. Now, over the last 50 years, traditionally, light source that have been used for infrared can be as simple as just a light bulb, you know, like this tungsten filament light bulb. These are what we call incoherent light. The incoherent light, just to give you an example, if I'm looking at a sample particle, which is about 10 micron here, I have a light that is spread all over the infrared reflective surface, okay? Now, the good thing here is that I can look at multiple particles simultaneously with this incoherent light. The not so good thing, okay, is that the signals can be relatively weak. And therefore, a technique known as Fourier transformation has been applied, which is basically a mathematical amplification of the signal through, well, you know that light and light will have a constructive interference. So we're using constructive interference in FTIR. That's why you have the term FTIR, all right? And the other thing is also measures the empty space. For example, between this particle and the next, there's an empty space. That also gets measured. So this adds on to the data processing, and that can give rise to increased measurement time, where we have to measure a large surface area. Okay, and for the particle of interest here, only a tiny fraction of the light that we passes on is actually absorbed. So therefore, can we improve upon this? Okay, this has been something that's troubling infrared scientists over the years, and I'm happy to announce that now we have a solution. Use a coherent light source, and that coherent light source is in the form of a quantum cascade laser. Don't let the word frighten you. It's just a super cool light source, all right, that is coherent. Now, I apologize if this is a little bit technical, but just to make sure that we are all on the same platform. So we make use of the fact that the semiconductor lasers, we do have this thing called the conduction band and the valence band. As the electron moves between the conduction band and the valence band, all right, energy in the form of electromagnetic radiation is released. And if we can do this through an energy well, so this electron comes down here, tunnels through the well, goes to the next, tunnels through, goes to the next, tunnels through, etc. So this is what we call a cascading process. And in this manner, we can generate a very specific energy of light, okay? And that's where the term quantum light is generated. The cascade is when it's going down, okay? And with that, we now have a totally new coherent light from a semiconductor laser. And if I'm looking at this particle, I can pass all that light into that particle, which means I don't waste the light energy anymore. Okay, it gets absorbed. And because of that, you notice that we do not have any FT anymore. Okay, so this is where Agilent is innovating, and that's why we call it the next generation infrared solution, because gone are the days of the Fourier transformation infrared. And if you know, in FTIR, you need a beam splitter, and usually that's made of potassium bromide, and it is a salt crystal. So when you have water, just like in Singapore now, it's raining heavily, Indonesia probably, okay? So when you have high humidity, the salt crystal will melt, so you have to protect it. So we don't have that features now. In fact, this instrument does not require you to put it into a special box or with those humidifier, removing of moisture. So it's ready to rock and roll when you have it. Okay, I use the word rock and roll because remember we're talking about dance of the molecules here. That's why I'm very moving around. Yeah. Okay, so we've got this new instrument architecture, bright laser light that shines onto the particle, and because we have very targeted analysis, it can take just as short as 1 second per spectrum. It's 30 times faster than the previous coherent light source. Okay, so this provides real-time processing and feedback to us, and because all light reaches the sample, and this is where when we develop this LDIR, what do you think would be one of the immediate applications? This is a very hot topic. I think you all know about it. Microplastics, yes. Some of you may have heard of Greta Thunberg. She has the same age as my daughter now. So both the young people are telling us, hey, don't use so much plastic because of these things here. I'd just like to point to you, and I just downloaded this just now, yeah. From the Jakarta Post, microplastics has entered our bodies via food chain. Scientists from LIPI has reported. Okay, this is from January 17, 2019. And this is not too surprising because if you look at this next picture here, you know our penyu, yeah, our turtle, sea turtle, their natural food would be this jellyfish. But when we throw plastic bags that are transparent into the ocean, it looks like the jellyfish to them. So they will also think that it is food. And because of this, this is where the problem is. All right? And this can lead to a lot of sad cases of whereby they found that the turtle dies, and when they open the stomach, it's full of all these plastics. All right? So mankind over this decade or this century itself has polluted a lot of our oceans with all these plastics. And this is a slide that I took off one of the island resorts. This was the seawater, and on top you can see the ocean. You see a bit of plastic in there. Okay, and this microplastic is really an emerging contaminant in the environment. However, the problem is their identification and quantification are not fully developed. Scientists all over the world today are rushing to first standardize on a method to identify and quantify. All right, the infrared 50-year-old technique is coming to the rescue as well. Okay, doing our small part to address this. I'm not sure if any of you caught this on Netflix. It is available on Netflix. This is a very nice documentary called A Plastic Ocean, where you can have more information about the seriousness of microplastics. Plastic used to be called wonder chemicals in the 50s, all right? These wonder chemicals, there was this nice advert by WWF, and it's telling us that based on the food that we are eating today, we are consuming this credit card size of plastics in about a week, okay? So that will cause you to think twice. And that Jakarta post that I mentioned just now, just to give you a little bit more details, is that the LIPI researchers actually found approximately 89% of anchovies. Anchovies in Indonesian is known as ikan teri. Okay, okay, you can see ikan teri. Yeah? Most of us, some countries like Malaysia call it ikan bilis. Yeah, so it goes very well with nasi uduk. Okay, so and your sambal. So we need to make sure that we're not having so much of this microplastic in there. And because of that, we need to qualify. We have to find a way. So at Agilent, we have worked out this workflow to help our customers in terms of sample preparation, how we will do it. Basically, you have your sample. It could be in the form of, for example, this could be seawater. You try to extract the microplastic into an organic solvent. All right, and we put that extracted organic solvent onto what is known as a cathode slide. This has a gold reflective surface at the bottom so that infrared light bounces off and we can detect that light. And then the analysis workflow where Agilent has developed a new software called the Clarity software to help us locate the particles where the particles are. And the next thing is shoot our laser onto it. Yeah, okay. So, and then we acquire the spectrum, compared to known library, and update the statistics. Now, sounds so simple, isn't it? Let me show you a short video on how this is being done. Okay, so let us look at that video demonstration. So this video will show you through the analysis in about a minute time for microplastics. So this
After
is
preparing your sample and placing it on a special microscope slide, you then place the slide in the instrument and select a method of analysis. A microscopic view of the sample is shown. You can then select an area of the sample for analysis. A detailed scan maps the location of each particle in the selected area. A second scan at higher resolution is then done to confirm the location and size of particles. An IR spectrum of each particle is collected, matched against a spectral library, and the results are updated, all in less than 8 seconds per particle. As the particles are identified, statistics showing the relative quantities of each plastic type are displayed. A range of other statistics, such as the number of particles in each size range, are also available. By clicking on a particle, you can see what type of plastic it is, its size and shape, its spectrum, and the level of confidence in the spectral match, and thus the identity of the plastic type. The software also allows you to perform various statistical and visual analysis tasks. Here, you can see a color-coded map of where each different type of plastic particle is located on the sample surface. The Agilent LDIR is a fast and accurate solution for microplastic analysis.
So, the Agilent microplastic solutions, in terms of sample throughput, very quickly, we can do 8 samples per day. Using the alternative FTIR, we can only do 2. So this is like 400% in terms of productivity improvement. In terms of incremental revenue, all right, we are looking at incremental revenue of 4 times, you know. So if you're generating 42,000 USD with the conventional FTIR, with the Agilent LDIR, we are looking at 150,000 US dollars, provided the revenue per sample is about 500 US dollars per sample. Okay, so good money. So on that note, this brings me to the end of my presentation. Hooray. Okay, so Agilent next generation spectroscopy solutions. The solutions we have developed allow you, our customer, to achieve trusted answer performance for the most demanding samples, achieve simplicity of operation to reduce learning curve required, and to achieve increased profitability through improved sample analysis throughputs. So on that note, over to you, Melda. I'll just run this one for them to have a look at our spectroscopy portfolio very quickly. Okay, over to you, Melda.
All right. Wow, thank you, Stephen, for the wonderful sharing. And this is definitely useful to save our laboratory productivity and efficiency. Now we have come to the Q&A sessions. To ask questions, please select all panelists in the drop-down menu and type in your question in the text box below. And feel free to use either in English or Indonesian language, whichever more convenient for you. So let me see for the question. Okay. Okay, we have questions.
Oh, we have. Okay.
All right. What is the unique feature of the AI-powered 5800, 5900 ICP-OES from Agilent? And how does this compare against other non-Agilent ICP-OES system?
Well, I guess if I have to pick up one, a very good question there actually, is that with the artificial intelligence built-in software, one of the features which you don't find on other ICP-OES is the ability to recommend wavelengths that you have not programmed into your method. I gave the example of the US EPA method, where if you have aluminum interference on arsenic, how the system can recommend an alternative better wavelength than what is recommended by the standard method. All right. Now, on other ICP-OES, you probably have to rerun the analysis on the second wavelength because you did not specify it in your method. So this is one of the unique feature I think that is worthwhile highlighting. Yeah, thank you for the question.
Okay, let's see if there is any next question. What is the unique about the light source used in the Agilent LDIR, and how does this compare against conventional FTIR system?
Another great question. So, as I mentioned, it is a semiconductor laser versus a normal light bulb. Okay, so but technically, we have moved on to a coherent light source where all the energy of that laser is actually shown onto the sample that is identified. You saw in the video how what we do first of all is we capture a white light image of the sample that allows us to pinpoint the location of the microplastic particles. That's the white light. And then after that, the quantum cascade laser would then be shown very specifically onto each of those particles. All right. Now, if you use a traditional light source, the light will just shine on the entire surface. So if I've got 100 particles in that light surface, it's like spread all over, including the blank spaces in between the particles. So the energy, the light energy is kind of wasted. Okay. So on the QCL, on the Agilent LDIR, no light energy is wasted. I hope that simplifies the explanation.
Okay, and then maybe we'll just take one last question. How is the fast analysis speed facilitated on the Agilent 5800 ICP-OES?
Analysis on the Agilent 5800?
Yeah, 5800, 5900. How is the fast analysis speed facilitated?
Okay, one of which is the, as you can see in the presentation, we have this new optical system. That new optical system allows us to reduce the size of the polychromator. And I brought the analogy if we have to turn off the instrument at the end of the day completely, and then the next day we turn it back on, it will take us half the time to get up to operating temperature as compared to our competitors or even our old models previously. All right, that gives you like at least an hours of head start. Now, the other thing is, while most of the other competitive ICP-OES in the market require purging of the detector, now the Agilent ICP-OES is hermetically sealed on the detector, so which means that we do not need to purge the detector. And because of that, we can actually turn on the plasma almost immediately, all right, when we first turn on the instrument. Okay, so let's say or on another situation where you've kept the instrument on a standby mode, the moment you turn on the argon gas, you can immediately ignite the plasma and you can do your analysis after about 15 minutes of warm-up.
Right, I guess we are near to the top of the 45 minutes, and as the time is limited today, if we did not get into your question today during the webinar, we will follow up with you afterwards, or you can actually drop a note to our authorized distributor, PT Unitama, and we'll be able to answer your question from there. And ladies and gentlemen, we have come to the end of our presentation. Hope this session has been very useful for you, and we would like to thank you again for attending this event. And thank you and have a good day and weekend ahead.
Thank you. Terima kasih. Bye-bye.
Terima kasih.